Hey, you indeed. Welcome to math lesson number 6. Today we are going to do fluency, an application problem, and concept development, which remember is a new lesson. And this can feel kind of hard, but remember, you can do hard things. The last lessons were hard, but some of us worked together a ton on Teams this week live, and we did a lot of work together, and people really learned how to convert mixed numbers to improper fractions and the other way around. So you can do hard things. A lot of distance learning has been hard, but you can all do hard things. You just need to push through and keep working and trying, and ask for help when you need it. I can give you tons of help, so ask for it. You need your whiteboard and your marker or paper and pencil. So if you don't have that, go get it now. Press pause. Come back. All right, so let's get to our fluency. Today we're going to practice what we've been practicing the last couple weeks, renaming fractions and mixed numbers with number bonds. Most of the people I've been working with love to use number bonds, so we're going to use that today. And the first thing I want to remind you is that anytime we have fractions greater than 1, and actually it's also fractions that are 1 whole too, but mostly we talk about it with fractions greater than 1. Anytime a fraction gets greater than 1, you can name it as an improper fraction or as a mixed number. So let's take a really easy one for an example. Let's see if I have 3 halves. Oops, 3 halves. I can say that 3 halves is 1 half plus 2 halves plus another half, 3 halves. Improper fraction form is 3.5. But that's really easy to see, like, okay, but also if you have 1 half and then 2 halves, 2 over 2, that's 1 whole. Think about it with measuring cups. 1 whole, but there would be another half left over, 1.5. They mean the exact same thing. If you were pouring milk for a recipe into a measuring cup that had half a cup, 1 whole cup, you would pour 1 half in, then 2 halves, and you would have a whole cup. You've probably seen this on iReady. They always use that on iReady. But then you need 1 more half. So you'd have 3 halves altogether, but would also be 1.5. They mean the exact same amount. They're just in 2 different forms. Improper fraction, mixed number. Remember, it's just like the languages we've talked about. You can take any word and translate it from Spanish to English or any other language. Mesa means table. Table means mesa. They mean the same thing, totally different letters because 2 different languages say it different ways. All right, so let's try another one. Now I want you to write with me here. We're going to do it a little faster. Some of you know how to do it so well. If you feel like you need a little bit slower time, keep pausing. Look at my directions here on the side. 15 fourths. Oops, excuse me. 15 fourths. Okay. 15 fourths. Everybody, is that an improper fraction or a mixed number? Good. Improper fraction. Now, it doesn't mean it's wrong. It's just that the numerator is bigger than the denominator. So no longer is it a piece of something. It's got a bunch of holes in it. How many holes? How many holes are in 1 whole if we're talking about fourths? Awesome. 4 fourths. So let's number bond out 4 fourths. That's 1 whole. Now, some of you might be able to go straight to all the holes in there. Most of the people I've been working with online, though, like to do it this way, so I'll do it this way with you. So that represents how many holes? 1. Good. Can we pull out another 4 fourths? We had 15 to begin with. Yes. Awesome. How many groups of 4 fourths have we taken out? 2. That represents 2 what? Holes. Good job. 1 hole, 2 holes. But how many fourths is that all together? You have to count by 4s. Good job. Let's do that. 4, 8. Can we pull out another one? Do we have enough in 15? Yup. Great. Pull out another one. How many do we have now? 1 whole, 2 whole, 3 whole. Great. 3 holes. But how many fourths is that? How many have we gotten up to yet? Count by 4s. Go. Did you get 12 fourths? Great. Are we done? Good. We have to go back up here and say, wait, how many do we have all together? 15? We got 12 down here. Can we pull out another 4/4? No, I hope you said no, because that would be how many? 16/4. So how many do we have here all together? You said 12/4, right? How many are left over then? Keyshawn has really gotten good at this. 3/4 are left over. Here is almost our mixed number. We're almost there. Go back and look. How many holes did we count out? 1 hole, 2 hole, 3 hole. So our mixed number form is 3. And how many fourths left over? 3, 3/4. Say the equivalent fractions with me now. 15/4, good, is equivalent to 3 and 3/4. That's how you say mixed numbers, remember. 3 and, there's no and symbol there, but you still say and, 3/4. Now, some of you may be seeing the trick here. I hope you maybe are. Ryan does this really good. 3 times 4 is 12. Remember, that's what we had down here anyway. So this is like a little shortcut. 3 times 4 is 12, plus the numerator, plus that guy. 12 plus 3 is 15. 15/4. That's a shortcut way. All right, let's do another one. Erase, erase, erase. I like this tool. It's cool, right? All right. 3 and 2/7. Let's go the other way now. If you know how to do what we just did easy, you can do this one easy. Now, I'm going to let you do this. I want you to start. I'm going to start filling in the blanks, but I want to help you less and see if you get the right answer. Number bond it out. Remember, what we're trying to get to is one improper fraction. Just going the opposite way. Think about the whole number first. Think about how many units, fractions, or what the unit fraction is and how many of those unit fractions you need to make a whole. Awesome. So you should have, we're talking about what unit fraction? 7ths. Good. So you should see, all right, well, in one whole, if we're talking about 7ths, we got 7/7. Do we only have one whole there, though? No, so we have to number bond out more. How many more do we need to number bond out? Nice, 2 more to get to 3. There's another 7/7 and another 7/7. How many holes do we have represented here now? Great. 1, 2, 3 holes. Is that it? No, not quite done. What else is still there? Great, the extra 2/7. Now, how are we going to get this improper fraction here with a number that's greater than the denominator up here? We know we're going to have 7ths. What do we have to do with these down here? Nice, we got to add them up. 7/7 plus 7/7 plus 7/7 plus 2/7. What do we get? Going to count by. Good. I hope you got your answer. You should have gotten 7, 14, 21. 21 plus 2, 23. 23/7. Now you want to check with the shortcut. Remember that shortcut I just told you? Goes the opposite for mixed number to improper. 3 times 7. We multiply the whole number times the denominator. 3 times 7 is 21. That's just what we did here. 21 plus 2. That's just what we did here. 21 plus 2, 23/7. Yep. So say this equivalency now. 3 and 2/7, good, is equal to? Good, 23/7. They mean the same thing. If I wanted to say, like in Spanish, I've been speaking a lot of Spanish over the break. Food. I've been helping families get food who aren't working right now. Food is the same as comida. They mean the same thing. but they're two totally different words with different letters, but they mean the same thing in two different languages. That's like what we're seeing here. This mixed number, it means the same as this improper fraction. They're just in two different forms, like two different languages. Great. Okay, let's get to the application problem now. The application problem is going to ask us to use this skill in real life. Remember, we use improper fractions and mixed numbers all the time in real life to think about time, to think about cooking, to think about distances. Today's example talks about cooking. Fill in the blank when I pause so you can make sure you're paying attention. Barbara needed, I hope you said it right, 3 1/4 cups of flour for her nice recipe. It's a weird word. If she measured 1/4 cup at a, how many times did she have to fill the measuring? So this is a problem I do all the time when I'm cooking. This is not really, but you can see it easily. Pretend that this was 1/4 of a cup. That means I need how many of these to make 1 whole cup? Good, 4. She needs 3 1/4. So she needs to make all these add up to 3 whole cups and then 1 more quarter of this for her recipe of flour. All right, so, but let's say she only has this measuring cup. That happens to me a lot because I don't have like a ton of measuring cups. So it'll say like, you need all this, but I only have this little bit. And so I always do the calculation in my head. Well, how many times am I going to have to fill that up? Let's figure it out. So she needs that many, but she has this to measure only. All right, so what do we know then? We know that, sorry. Okay, here we go. We know that she needs this much, 3 1/4 cup. We need to know how many fourths she needs to fill. So what do we have to get? A mixed number? No, good job. We need to find the improper fraction version of this. So let's do it. Number bonded out, find the total. Go. Pause the camera now so you can figure it out, then come back for the answer. All right, I hope you found the answer. You should have found an improper fraction, something over 4. I hope you did this. 1 whole of this is 4 fourths, because there are 4 fourths in a whole. Here's another one. Nice. Here's another one. Do I have all 3 holes there? 1 whole, 2 whole, 3 whole. Yup. Plus, I can't forget what else is there. Awesome. 1/4. Now I got to figure out my total numerator. How do I do that? I got to add these guys all up. 4, 8, 12, 13. 13 fourths. So what does that mean back in our problem? If she measured 1/4 cup at a time, how many times did she have to fill the measuring cup? Did we figure that out? I bet Keyshawn's going, yes, that's what we did all week last week on Teams. Yep, she has to fill it up. How many times, Keyshawn? Nice, 13 times. 1, 2, 3. It's kind of annoying, but if you only have a 1/4 measuring cup, you don't have any other choice. Okay. Let's move on now to our new learning. Today's concept development just adds in one skill that we've actually already done. So today's lesson is almost kind of review, except that it's putting some skills all together that we just haven't done all together before. Today we are going to be comparing fractions greater than 1. And in your head you should be like, greater than 1. I know what those are. Fractions greater than 1 can be either this or this. What are the 2 things they could be? Great. I can imagine Madison going, improper fractions, or Jasmine would be like, or mixed numbers. Cynthia would say, yes, they will mean the same thing. And Kaylee might say, but in different languages. Kind of. You could think of improper fractions as a language and mixed numbers as a language. All right, here we go. Back to the problem. Same character as before. Barbara needed 13/4 cups of flour. Sometimes we call those quarters too, right? Same amount that we were just dealing with. Okay, so remember, we already knew she needed that. Okay. Her friend Jeanette needed 9/2 cup of flour. And her friend Robert needed 3 6/8 cups. Let's compare the amounts using a number line. Like, what if you wanted to know who needed the most flour for their recipe? Some people don't like to eat flour. Some people, flour makes them kind of sick. So maybe they were all baking brownies, let's say. And you could choose to eat any one of their brownies. But let's say you realize you have a flour sickness and like your tummy kind of hurts if you eat a lot of flour. And so you want to eat the brownie that has the least amount of flour. And Barbara said, well, mine has 13/4. And Jeanette said, mine has 9/2. And Robert said, well, mine has 3 6/8. Whose would you want to eat if you wanted the least amount of flour? Well, let's see. So here's our steps. Step 1, fill in the blank when I pause. Make number. Good. Now remember, when we're making a number line, we always want to ask ourselves, where should it start? Where should it end? So keep that in mind. Step 2, rename improper fractions to mixed numbers. On a number line, you can use either, really. You can see either. We've done that many times in the past lessons. But for our use today in comparing, we're going to make them into mixed numbers. And then use benchmark, which remember we always call them famous fractions, to find each mixed number there on the number line. Then compare each. Say things like blank is greater than. Eventually we'll use the greater than or less than symbols in the next part. Maybe you might even find some equal to. Here we go. Let's make our number line. This is the first thing. And we're going to ask ourselves, where should it start and end? Well, what are the fractions I have again? I have 13/4. I have 9/2. And I have 3 6/8. Well, I know I may not have to deal with 0. So sometimes we start a number line at 0, but right now it seems like we're going to be thinking about numbers bigger than 0. Like 1 for sure is bigger than 3. Let's try this one at 13/4. We already did that in the last one, so this should go quick. 13/4 as a mixed number because right now it's what? Yep, it's improper. Good. I can pull out 1/4 in the number bond. Oops, sorry. Oh, I don't want to stop presenting. Oh, I don't want to stop presenting. Oops. Why is that happening? Hey, I'm in the middle of a lesson, Mr. Core. Will you say hi to everybody?
Hello, everyone. It's Mr. Gore reaching out.
I'm actually, I'm just using the whiteboard function, so I'm taping right now. Can I call you back?
Yes, definitely.
Sorry.
I just got off another one, too.
Okay, I'll be right back.
Bye, everyone.
Okay, see ya. Okay, here we go. Sorry, let's try that again. 13/4. Oops. So number bond out 1/4, 1 whole. We could do another one though, right? Or 1 whole. Oh, and just keep bumping into that. Another one, 4/4. Remember that gave us 12/4, but then we said there's one more left, right? So what whole number did we, or excuse me, what mixed number did we say 13/4 is? 13/4 as a mixed number is 3 1/4. So, so we know this one is 3 and something, and we know this one is 3 and something. 3 1/4, 3 6/8. So it seems like maybe these are all going to be between what whole number and what whole number? Say it. Nice. It's going to be between 3 and 4. I always like to leave some space at the end in case I need more space. But right now, let's say 3 and 4. So the first one was what? 3 1/4. So if this is 3, where would 1/4 be more than 3? What would I have to partition this hole between 3 and 4 into? Good, fourths. Here's where our benchmark fraction stuff comes in. Here's half. What do I have to do to the half to get fourths? Nice, I can hear Tyja say, split it in half again. There's a fourth. So here's 1/4. Here's 2/4, 3/4, and 4/4. So I could label them all, or I could just label what I need. I know I need to think about 3 and 1/4, so I'm going to label that. Here's 3, so here's 3 and 1/4. Can get rid of this now. Having Mr. Cork come in made it kind of feel like we were in class, and he stepped in and said, "Hey, Wendy." that was fun. Okay, made me feel like we were back at school. So here's 3 and 1/4. All right, and let's do 9/2 now. All right, so what do we have to do to 9/2? Awesome. I hope you said convert it. Convert it into what, though? I'm going to convert it here because I keep getting messed up when I draw it down there. This whiteboard, I guess, doesn't have as much space as I thought. So I'm going to convert 9/2 into what? Nice. I'm going to rename it or convert it, either one, into a mixed number. So I got to pull out the wholes. But we're talking about halves, not fourths. So what do I have to pull out? In halves, how many do you need to make a whole? Yes, 2 halves. Awesome. 2 halves. Can I pull out more? Great. Pull them all out and figure out what you got. I'm going to be quiet and do the work. You look down at your work, figure it out, pop up when I say let's compare our answers. Do your work. Do your own work. I know you know how to do this. Don't look at mine. Tyrese, stop looking at mine. 2, 4, 6. Up. I see Cynthia's eyes. Cynthia knows. I see Amari's eyes. Amari knows. Oh, I heard Kaylee say 2, 4, 6, 8. And then I hear Ryan yell out, 1/2 left. Nice. Let's just double check. Let's count by twos. 2, 4, 6, 8. 8 halves plus 1 more is 9 halves. Great. So how many do we have there? 1 whole, 2 whole, 3 whole, 4 whole. Uh-oh, this goes above 4. Good thing we left some extra space on that number line. So if 4.5 would be maybe all the way here at the end. Can this move here? No. Uh-oh. Well, there's my half. There's 4.5. Okay. Let's go back to and label what they were as improper fractions so we remember. This was 13/4. This was 9/2. Oops, that makes it look like a fraction, sorry. This was 9/2. They mean the same thing, just as a mixed number and as an improper fraction. And then we got this last one. Luckily, it's already done for us. 3 and 6/8. Now we just need to use benchmark fractions to figure out where it would go. There's 3 1/4. There's 3 1/2. So where would 3 and 6/8 be? Well, where would 8s be altogether? We could partition this up into 8s, right? You know how to do this. If this is already partitioned into 4ths, how could you very easily and quickly get 8s? Think about it. What is the connection or the relationship between 4 and 8? Nice. 4 is of 8. 4 is what? Half of 8. Nice. So I could totally imagine right now Amaje going, split them in half. Split those fourths into halves. There we go. There we go. There we go. There we go. Now we should have what between 3 and 4ths? 3 and 4? 8. Good. Count them. 1, 2, 3, 4, 5, 6, 7, 8. Yes. There's 6/8. There's 8. So where would 6/8 be? 1, 2, 3, 4. And that makes sense because 4 is half of 8. 5, 6. 6/8 is here. So this is 3 and 6/8. So let's go back to the beginning of our problem because now we have all 3 numbers here on the number line. Our problem asked us to compare those amounts. And I added on like which one has the least amount of flour? Which one is the lowest on the number line? Nice. Yep, 13/4. Barbara's brownies has the least amount of flour because that's the same as 3 1/4. The next one up, the next one bigger is 3 6/8. And the largest one was 9/2. I wonder if anybody thought that would be the largest, even though the denominator was the biggest. Or was the number in the denominator was the smallest, but halves are actually bigger than 4s or 8s, right? So 9/2 turns out to be bigger. Okay, great job. So now I'm going to give you 2 quick more problems. I'm going to give you a little less help, and I'm going to pause a little bit more so you can do the work yourself. So make sure you have room on that paper, get another piece of paper, or wipe off that whiteboard, and let's do 2 more. Okay, so comparing 5 3/4 to 5 3/8. Think about first on your number line. What are you going to make your number line as? Between what and what? Between 3 and 4? Nope. Great. I hope you said between 5 and 6. Now we have to figure out where 5 3/4 is. So what do I have to partition this chunk between 5 and 6 into? 4ths. Great. Half, then 4ths, like we always do in class. That gives you easy 4ths. Where's 5 3/4? Plot it. Great. 5 3/4 is here at the 3/4 line. Is it 3/4 more than 5? Great. Okay, now what about 5 3/8? This is connected to the last problem. You have to do the same thing here with the partitioning. What did you have to do to make 8s before? I hope you're already going back there and saying, oh, just split those 4ths in half. Then you get 8s. So where's 3/8 now? Great, right before the half mark. So 5 3/8 is here. And we can very easily see now which one is bigger. 5 3/4 is bigger. Maybe in your head you already knew that because you were like, well, 4ths are bigger chunks than 8s. So if I have 3 bigger chunks, that fraction will be bigger than smaller chunks and having 3 of those smaller chunks. That's another way that we used to compare fractions before. So which one is bigger? I can't draw in here, but your arrow should point to the 5 3/4. Good. Go the other way on that. Here. Okay. Next one. Last one. 7/2 versus compared to 7/3. Okay, get your number line. Step 1, think about how big should your number line be? Ooh, this one is a little different. What do you have to do first? Jasmine is a super pro at this. I'm sure she's already like, you got to turn that improper fraction into a mixed number. Go. Come back to me to check. Don't watch while I do it because I want you to check on your own and see if you know how to do it by yourself. Don't look at mine. Keep working, Tyrese. You can do this. Tyja, you can do hard things. You know it. You do them all the time. Yes. Keep going. Oh my God, Karen, is that you? I haven't heard from you in weeks. Jasmine, hi. I miss you. So glad to have you here finally. Okay, great. So, tell me, what should this be between? How many holes do we have here, Karen? 3. 7/2 is what? Everybody. 3.5. Great. So my number line should be between 3 and what? What 2 whole numbers? Awesome. I bet you Stephen already had this on his paper, and I bet you Cynthia was like, That's so easy. 3.5 is right here. Great. Now let's go back and do 7/3. Where would 7/3 be? What do I have to do, Kaylee? Yes, I got a number bond out 7/3 to make it a mixed number. Go, do it by yourself and then check me, check you. Don't watch me do it. Don't watch me do it. It's even faster. What is 7/3 as a mixed number, Keyshawn? You're a pro at this. Awesome. 2 1/3. Because I got 2 holes here. Oh, wait. Yeah, 2 1/3. 2 1/3. Maybe like me, you were like, whoa, 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 whoa. I can't put 2 1/3 here. You're right. That's okay. Let's erase. Good thing we have an eraser. I'm going to keep 3 1/2 on there. And let's say 4 is right here. 4 is here. 3 is here. You guys can work on number lines like this. You can change your number line any way you want, anytime you want. 3, 3.5, 4. So where would 2 1/3 be? If this is 2, 1/3 would need me to partition this into how many? Yep, 3. Here's 2 1/3. But you probably already knew that without even having to do this. It was pretty obvious to tell which one was smaller before I even drew that. 2 1/3 is much smaller than 3.5. So 2 1/3, which is the same as 7/3, which one's bigger, 7/2 or 7/3? 7/2. All right, everybody. Your assignment is on math assignments number 6. If you want more practice with mixed numbers and improper fractions, go on to Flowcabulary. The class code is there. Not too many of you have done it, but it's great extra practice and it's a good wrap. All right, awesome work. Can't wait to see your answers. If this feels hard, it's okay. It's new work. It is kind of hard. Call me. We can do as much work as you want together. Love you. Bye.